Hello everyone, this is Mr. Flatness, and tonight we'll be discussing and looking at section 5 of chapter 2, multiplication of real numbers. Our goals for this section will be taking a look at multiplying real numbers, and again we'll be using properties of multiplication, as well as continue on within our classwork of multiplying those numbers to solve real life problems. So for multiplying real numbers, we have a couple of rules here to take a look at. You can write out the long particular rule, which states that the product of two real numbers with the same sign is the product of their absolute values, and the product of two real numbers with different signs is the opposite of the product. But that doesn't mean as much maybe to you as remembering this. And you can write this down by saying, hey, a positive times a positive is going to be equal to a positive. We also know that a negative times a negative will equal a positive. So again, talking about if I'm multiplying two numbers with the same sign, I'm always going to get positive. And if I'm going to deal with different signs, a positive times a negative, or vice versa, my answer is always going to be negative. One final thing that I want to talk about is that if you have an even amount of negatives, your answer will always be positive. And finally, and I can put this up here somewhere, if I have an odd amount of negatives, your answer will always be negative. So, some rules to apply. The definition they give is kind of confusing, but if you remember what you learned back in 6th and 7th grade about these kind of things in your notes, that makes multiplying real numbers go pretty quick. In our next slide, we're going to talk about the properties of multiplication. And just like the addition properties that we talked about a few sections ago, you'll notice that there's a lot of similarities. We have the commutative property of multiplication as well as the associative property. We have the identity property, the zero property, and then we have a property called the property of the opposite. So there's one extra property. So again, we need to put these in our notes. We need to study them and keep them straight in our minds. Have them ready to go by memory, because if you do, you'll be able to be very good at computation with multiplication and coming up with very quick answers that will be accurate. Again, I'm going to now start to kind of briefly explain these. Again, press pause so that you can write all these down, and then maybe press play to hear my explanations, which will maybe help you solidify these concepts in your head. So we'll start out with the commutative property, and that's the same as the commutative property of addition, which basically is saying the order, again, does not matter. And in the algebraic version here, or model, we have a times b is the same as b times a. So we know that 3 times a negative 2 is the same thing as negative 2 times 3. So again, I want to talk about the commutative property as this thing that we deal with when we're talking order. And the associative property, the next property, is the exact same version as the addition one. And so here we're going to be talking about the way that we group numbers when multiplying will not change the product, just like it wouldn't change the sum. So in looking at our example here in algebra, a times b, grouping the a and the b, and then multiplying c, will be the same thing as if I were to group the b and the c together first, and then multiply in a. So again, this thing, instead of order, now we're talking about grouping. And again, that's how you keep these two properties straight. Associative talks about grouping. Commutative just talks about order. So, the third property that we'll talk about is the identity property. And this is a little bit different than the addition property, simply because here we're going to, in order for a number to keep its identity in multiplication, we need to multiply that number by 1. When we're talking the identity property for addition, we were adding 0 to that. So that's how you keep the two straight. If we want a number to keep its identity with multiplication, we multiply it by 1. So negative 4 times 1, negative 4, identity property. The property of 0 simply states that any number times 0 will always be 0. So in our example here, we have negative 2 times 0 is 0. Finally, we have the property of the opposites, and basically what we're saying there is the product of a number and negative 1 is the opposite of that number. So if I'm going to take a and multiply it by negative 1, I'm going to get negative a. So if I take the number negative 3 and multiply it by a negative 1, then I'm going to get the opposite of that number, which is 3. So again, study these properties. Have them down by memory so that you can draw on them when you're working with problems, because it will make the computation that much faster by you allowing to see patterns and using those patterns to make your computation quick. So in our next slide we have two examples of multiplying. In the first example here we have four numbers that we want to multiply together to find the product. Just like we have four numbers we want to find the product of in problem number 2. I want to point out for number 1, notice how many negatives you see. We see 1, 2, 3, 4 negatives. So again, with 4 negatives, I know then that my answer will be positive no matter what. Okay, so looking at an even amount, 4 is even. So I have an even amount of negatives, so no matter what I'm going to have an even, or I should say a positive answer. So now I can just take a look at multiplying these numbers out. So I'm going to multiply negative 2 times half, negative half, times negative 3 times negative 5. Right now I'm really not interested in the sign because I know that in the end my answer is going to be positive. So simply all I need to do is deal with the digits. So 2 times a half. Well, a half of 2 is 1. And then I want to take 1 times 3 times 5. Again, I mean, I know that I'm dealing with signs here, but again, I'm going to go back to knowing that my answer is always going to be positive, so I'm just going to deal with the digits. So 1 times 3 times 5 is going to be positive 15, and that's going to allow me to do things very, very quickly. In the next example of number 2 here, notice now I have negative 4 times negative x again times positive x. Notice here I have 3 negatives, which is an odd amount. Well, if I have an odd amount of negatives, then I know that my answer is going to be negative. So now I'm just going to look at multiplying the number or the terms together. Okay? So notice here I have a constant term of negative 4, but then I have variable terms. So x times x, since we don't know them, x times x would be x squared. So if I have x times x times x, then that's going to be x cubed. So I'm going to have my variable term as being x cubed, and so then I'll deal with negative 4 times x cubed as the most simplified answer possible, and that would be its answer. Once I know what x is, then I can plug that in, and then I could get an answer that would be a constant term at the end. But for now, this is the most simplest terms possible, negative 4x cubed. Our next example here, or slide, we're going to be looking at evaluating expressions. And so now I am going to evaluate when I know that x is negative 7. So all I need to do is take a look at problem number 1 here, and wherever I see an x, I'm going to put a negative 7. The other thing I'm going to notice is this. I'm going to take 2 times negative x, or what we would say is the opposite of what x is. And I'm going to do that again, times the opposite of what x is. So in looking at this, I'm going to plug in negative 7 for x. So 2 times the opposite of what x is. So the opposite of x would be, so I'll just put in x there. And then we'll go the opposite of what x is again. Okay, so the opposite of negative 7 would be 7. So that's going to be 2 times 7 times, again, the opposite of negative 7 would be 7 again. So my new problem becomes 2 times 7 times 7. I can change the order using the commutative property. Maybe deal with 7 times 7 for 49. And then if I want to take 49 and double it, I would get 98. So this can be kind of tricky, this negative x concept. We are saying, instead of saying negative x, we're saying that we want to find the opposite. This here is saying the opposite of what x is. So if x is negative 7, I want its opposite, which would be positive 7 in both cases. Now another way to do this problem is to kind of combine the expression that we have starting with first. And so I know that a negative x times a negative x is going to be a positive x squared. So I could say, to redo this, by just saying that is going to simplify to 2x squared. And then I can plug in my negative 7 into my variable. So then that's going to be 2 times negative 7 to the second power. So then using PEMDAS, I deal with exponents first. Negative 7 squared would be positive 49, and 49 times 2 would give you 98. So it doesn't matter which way you go about it, you're still going to get the same answer. And it's just vital that you show your work. So whichever way you decide to go about it is kind of up to you. In example 2, we have the expression negative 5x times negative 2/7. So looking at this, again, I want to substitute negative 7 in for x. So I'll rewrite it underneath, and this is kind of how we want you to show your work as well. Write down the problem and then show your work going down the page. That's the goal here. So I'm going to take negative 5. I'm going to multiply that times a negative 7. So notice I have nested parentheses in here. So I'm simply doing that to show negative 5 times negative 7. I'm going to do that first. Now I'm going to multiply whatever that product is times negative 2/7. So here I don't see any advantage to, I guess I could use, since I've grouped the terms now, I could use the associative property. I could simply rewrite this as negative 5, and then I could multiply that times negative 7 over 1 times negative 2/7. Simply because now I can cancel or factor out a 7 like that. So now I can take care of the right hand side first. So that would be negative 1 times a negative 2 is positive 2 over 1, which is 2, and then negative 5 times 2 would be negative 10. So here are your practice problems for tonight. We have 3 of them, so again, put those at the top of your homework paper that you have. Simply just find the product of the first 2, and on the third one, evaluate the expression when x is negative 3. Hope you have a great night, and we'll see you tomorrow.